Okay, we are now recording. All right, so ladies and gentlemen, we got to get x all by itself on the left side of this equation. So how do we begin? Well, first of all, we need to get these terms out of jail. We're going to have to use our distributive property and distribute the 3 inside the parentheses. So 3 multiplied by x is 3x. 3 multiplied by a -2 is a -6. Now we want to solve for x, so we got to get x all by itself on the left side of our equation. To do that, we want to separate the variable terms on the left from the constant terms on the right side of our equation. And so now we're going to move this -6 over to the right side by adding 6 to both sides. And then we got 3x equals 12. Finally, what we're going to do is get this x all by its lonesome on the left side by dividing both sides of the equation by 3. And we get our solution as being 4 here. Okay. So solving more advanced equations. How do we attack them in general? Well, step number 1 is you want to try to simplify both sides of your equation first. Now, to simplify both sides of the equation, this may mean that we may have to use our distributive property. We may have to combine like terms. And once we do that, then we separate. We proceed to separate the variable terms on one side of equation and constant terms on the opposite side. Step number 3, once we separate our variable terms and constant terms on opposite sides of the equation, we then try to get the variable all by itself. And that's basically it. Now, back with step number 1, simplifying both sides of your equation. There might be some equations where we have fractions present, in which case we like to get rid of our fractions. Or we might have decimals. So maybe I should have said also get rid of fractions or decimals, whatever the case might be. All right, so in general, that's how we approach solving more advanced equations. Now, step number 2, involving separating the variable terms on one side versus the constants on the opposite side, involve using the addition or the subtraction properties of equality to accomplish that. Step number 3, to get the variable all by itself on the one side of the equation, involves that we use the division or the multiplication properties of equality. Okay. Any questions about that? All right, let's go back, see if we can dig up another equation to solve here. All right, let's drop on down. Let's drop on down to one like number 14 here. So we want to try to solve 1 is equal to 1/3 times 6x plus 3. So we're going to try to do number 14. The first move we put on this is we're going to have to distribute the 1/3 inside the parentheses here. So we got 1 is equal to 1/3 times 6x plus 1/3 times 3/1. So we got 1 is equal to, now 1/3 times 6x is 6x over 3. 1/3 times 3/1 is 3/3. But the 6/3 reduces down, 6x over 3 reduces down to 2x, and 3/3 reduces down to 1. Now that we simplified the right and left side completely, it's time to separate. Get the variables on one side, constants on the opposite side. Since I have my variable x on the right side, I'm going to leave it on the right side. I'm going to move this constant 1 over the left side. How do I move a positive 1 to the other side? I'm -1 from both sides. The left side goes to 0. 1 minus 1 is 0. The right side, the 1's drop out, leaving you 2x. Finally, now that we got the variable terms on one side, constant terms on the opposite side, it's time to get the variable by itself. Since this is 2 times x, we're going to have to divide both sides of our equation by 2. And 0 divided by 2 is 0, and 2x over 2 reduces down to x. Ladies and gentlemen, we have solved that equation for x. Any questions how we solve that equation for x? All righty. Now, the equation we just solved had only one fraction in it. And by distributing the 1/3 inside the parentheses, the fraction disappeared anyways. But ladies and gentlemen, if you look at problem like number 20, we have fractions everywhere. And something tells me that when we distribute the 1/3 and the 1/2 inside parentheses, we're not going to get rid of all the fractions. This is a case here where we would probably want to eliminate our fractions first. So problem number 20, to solve this equation for the variable x, to solve for x, we're going to get rid of these fractions first. And what's the least common denominator of 2 and 3? That's 6. What I'm going to do is I'm going to multiply both sides of my equation by 6. And by doing this, this is going to eliminate my fractions. And I'm multiply the right side by 6 too. Don't forget that. Now 6/1 times 1/3 is 6/3. 6/1 times 1/2 is 6/2. 6/3 reduces down to 3. Wrong. I don't reduce down to 3. What does it reduce down to? Six over 3 reduces down to what? 2, correct? There we go. 6 over 2 reduces down to what? 3? All right, now I'm going to distribute the 2 inside the parentheses here, in which case I'll have 2x minus 8. 2 times 4 is 8. 3 times x is 3x. And 3 times -6 is minus 18. Now we want to get x on one side of our equation. So that means we're going to have to separate our, now that both sides of our equation are simplified, we have to separate our variable terms on one side versus constants on the opposite side. So I'm going to bring this 3x over to the left side of my equation to join the 2x. And how do I move a positive 3x to the other side? I'm going to minus 3x from both sides. Now 2x minus 3x combine to give you -1x. These 3x's drop out on the right side, leaving you with -18. Finally, continuing to separate, I'm going to move this constant term -8 to the right side by adding 8 to both sides. The 8's drop out on the left side to 0, leaving you with -1x. And -18 plus 8 on the right side is -10. Finally, we get x by itself by dividing both sides by -1. -1x divided by -1 reduces down to x, and -10 divided by -1 reduces down to 10. And that would be your solution to that equation there. X is equal to 10. All right, any questions how we solve that equation for x, ladies and gentlemen? Solution is 10. Notice I got rid of the fractions first. I multiply both sides by the least common denominator. That always works. That always eliminates fractions in an equation. All right. So for classwork number 1, I'm going to have you try problem number 24. Try to solve that equation in number 24. Solve it for y, okay? We'll check back in a moment. Classwork number 1, number 24. So that'll be classwork number 1. All right, so anybody get the solution to this thing? On the left side, we have some simplifying to do here. So what we're going to have to do is we're going to have to distribute the -5 inside the parentheses. We're also going to have to distribute on the right side, distribute the 2 inside the parentheses. -5 multiplied by 4y is -20y. -5 multiplied by a -3 is a +15. 2 multiplied by 2 on the right side is 4. 2 multiplied by -10y is -20y. And now on the left side, there's no more simplifying to do, but on the right side, there is more simplifying to do. Must combine like terms. 4 plus 11 combined to give us 15. Now that both sides are completely simplified, it's time to separate the variable terms on one side, the constants on the opposite side. All right, so what do we discover here? If I move this -20 over to the left side by adding it to both sides of my equation, we see an interesting thing occur. The 20y's drop out on the left side of the equation, and they also drop out on the right side of the equation, leaving us with 15 equals 15. This is a true numeric statement, ladies and gentlemen. So we would say that this equation has an infinite number of solutions. All real numbers are solutions to this equation. So we would say there's an infinite number of solutions. This is called an identity in mathematics. Infinite number of solutions. Okay. All right, that'll be part of classwork number 1. Anybody get that answer? All right, we're gonna look at another one here. All right. So that was number 24 there. I'm going to do another one down here, number 36. Three times x minus 1 minus 4x minus 5 is equal to 2 times 5x minus 1. All right, so on the left side, we have some simplifying to do here. 3 needs to be distributed in. 3 times x, 3x. 3 times -1 minus 3. This is a negative sign that precedes this parentheses, so it's understood to be like a -1 that needs to be distributed in. -1 times 4x minus 4x. -1 multiplied by -5 plus 5. On the right side, we distribute the 2 inside the parentheses here. 2 times 5x, 10x. 2 multiplied by a -1 minus 2. On the left side, we have like terms that need to be combined. 3x minus 4x. What's 3 subtract 4? That'll give you -1. So 3x minus 4x is minus 1x. -3 plus 5 combined to give you plus 2. On the right side, what's -2 minus 7? Those combine to give you -9. So the right side simplifies to this. Now it's time to separate the variable terms on one side versus constants on the opposite side, since both sides are simplified. I'm going to move a positive 10x over to the left side to join the -1x. How do we move a positive to the other side of the equation? We subtract it from both sides. So I subtract 10x from the left, and I subtract 10x from the right. -1x minus 10x combine to give you -11x. The 10x's on the right drop out to 0, leaving you with -9. Continuing to separate, I'm now going to move this constant term 2 over to the right by subtracting 2 from both sides. The 2's on the left side cancel out to 0, they're gone, leaving you with -11x. And -9 subtract 2 on the right side is -11. Finally, we want to get x all by itself, so we're going to have to divide both sides of our equation by -11. And this implies then that x is equal to negative 11 divided by itself is 1. So our solution to this equation is 1. And that equation has been solved. Solution's 1. Any questions about that problem? All right. All right, sometimes our equation has a bunch of decimals in it, like number 54 here. And if your equation has decimals in it, we like to get rid of the decimals, just like we like to knock out the fractions. We've seen that to get rid of fractions in an equation, we multiply both sides by the least common denominator. To get rid of decimals, we have to multiply both sides of our equation by an appropriate power of 10. Because when you multiply a decimal by 10 or a multiple of 10, the effect it has on the decimal is to shift the decimal point to the right so many places, which then turns the decimal into a whole number. So in order to solve this equation that has decimals in it for x, in order to make both these decimals become whole numbers, we're going to have the decimal point shift at least one place to the right, which means we're going to have to multiply both sides of our equation by 10. So I'm going to multiply this term on the left by 10, both terms on the left by 10 rather. And I'm going to multiply the right side by 10. 10 times 0.3x turns this into a nice 3x. 10 times 6/10 turns 6/10 into 6. 10 times 12 on the right is 120. And now we have a much nicer looking equation, no more decimals. Continuing to simplify on the left side, we distribute the 6 inside the parentheses. 6 times 25 is going to be 150. 6 times negative x minus 6x. Combining like terms on the left side, continuing to simplify the left side, 3x subtract 6x combined to give you minus 3x. Now that both sides of our equation are simplified, it's time to begin to separate. Variable terms on one side, constants on the opposite side. I already got my x on the left side. That means I got to bring this constant 150 over to the right side to join the 120. How do we move a positive 150 to the other side of the equation? We subtract it from both sides. The 150s on the left side combine to 0, they cancel out, leaving you with just negative 3x. On the right side, 120 subtract 150 is negative 30. Now we just got to get the variable x all by itself on the left side of our equation by dividing both sides by negative 3. In which case we get x is equal to positive 10, and that would be our solution to that equation. X equals 10. Any questions about that problem? So there we got rid of all of our decimals by multiplying both sides of our equation by 10. That knocked all of our decimals out of the picture. Any questions with what happened there? All right, so part of classwork number 1, I would like you to do problem number 70 now. Number 70. We'll call this part of classwork number 1 also. So we're going to try to solve this equation that has a bunch of decimals in it. 0.11x, which is 1100ths x, plus 1200ths times quantity x plus 4,000 equals 940. All right, we're going to solve this equation for the variable x. This will be part of classwork 1. I'll give you a couple minutes to work on this. First, my advice is get rid of the decimals. So that means you're going to have to multiply both sides by not 10. 10's not good enough now. You got to multiply both sides by 100 to turn all your decimals into whole numbers. All right, see if you can do that. All right, so we want to get rid of these decimals first, so we're going to multiply both sides by 100. Got to multiply the right side by 100. 100 times 1100x turns this into a nice 11x. 100 times 1200ths turns this into 12. Decimals are gone. The right side turns into 94,000. On the left side, there's more need of simplifying. We distribute the 12 inside the parentheses here. 12 times x is plus 12x. 12 times 4,000 is going to be 48,000. No simplifying necessary on the right side. Combining like terms on the left side to continue to simplify the left side, 11x plus 12x combine to give you 23x. Now that both sides are completely simplified, it's time to begin to separate variable terms on the left side versus constants on the right side. I already got my variable term on the left side, so I'm just going to move this constant term 48,000 to the right side. How do we do that algebraically? We're going to have to subtract 48,000 from both sides. $48,000 drop out on the left side, leaving you with 23x. On the right side, 94,000 minus 48,000 is going to be what? I believe that's 46,000. Finally, to get x all by itself, we divide both sides by 23. Hence, our solution is going to be x is equal to 2,000. Anybody get that answer? X equal to 2,000. All righty. So we'll call that part of classwork 1, ladies and gentlemen. And that brings to a conclusion this section here. Okay. So section 10.3 is done. Section 10.4 is entitled Formulas. A formula basically is an equation involving 2 or more variables. Ladies and gentlemen, there's thousands of formulas out there in the real world being used every single day to complete various tasks. Many formulas out there. In fact, somebody out there is using the simple interest formula to compute how much interest somebody has to pay on their loan, maybe a student loan. Formulas are all around us, okay? All right, so section 10.4 is going to address working with formulas. A formula, again, is nothing more than an equation with 2 or more variables in it. Here's a formula. Y is equal to 3x plus 10. That's a formula. It's an equation that involves 2 variables, 2 different variables. Okay. Suppose I want you to, using this formula, I want you to find y when x is equal to 20. How would we solve for y when x is assigned a value of 20? Well, it's very simple. You just take 20, substitute it in place of the x variable in the formula, and then solve for y. So y is going to be equal to 3 times 20 plus 10. Y is going to be equal to 3 times 20 is 60 plus 10. Y is going to be equal to 70. We have just solved a formula in mathematics. Any questions how we just solved that formula? Number 12 looks interesting. They give us the formula y is equal to quantity x plus 1 squared minus 3. And they want us to find y when x is assigned a value of -1. So let's see if we can take this formula and solve for y when x is equal to -1. To do that, we replace the x variable in the formula wherever we see it with -1. So therefore, y is going to be equal to -1 plus 1 quantity squared minus 3. Y is going to be equal to, what's -1 plus 1? Well, that gives you 0. And what's 0 squared? 0 times 0 is 0. And what's 0 minus 3? -3. And that's what y would be equal to. Any questions how we're solving a formula for a variable given the value of the other variable? All right, formulas. Alrighty. All right, let's look at number 18. Now they give us a formula that involves 3 variables, y, k, and x. So y is equal to k times x squared. And they want us to find k when x is assigned a value of 4 and y is assigned a value of 32. So how in 18a are we going to find k when x is 4 and y is 32? Well, basically we plug and chug. I'm going to replace x with 4, and I'm going to substitute in 32 in place of y, and then we're going to solve the equation for k. Hence, we're going to have 32 is equal to k times x squared, x being 4, so 4 gets squared. Hence, we have 32 is equal to 4 squared is 16, so we have 16k is equal to 32. Now, to solve for k is pretty simple. All we got to do is get k all by its lonesome on the right side of our equation by dividing both sides by 16. 32 divided by 16 is 2. 16k divided by 16 reduces down to k. And look at that. I have solved that equation for k. Is that okay? Everything okay? How I solve for k? All right. So far up to this point, we've been taking a formula and we've been basically plugging in a numeric value for one or more of our variables and then solving for the remaining variable. Ladies and gentlemen, sometimes we just take a formula and we're being asked to solve it for a variable without knowing the numeric values assigned to the other variables. This is a skill that is very important if you go onwards into the sciences or into engineering, or if you get into computer science, computer programming. All right, being able to manipulate formulas and solve them for any variable that you desire to solve them for should be something, a skill that we should try to develop if you're going to go into the computational field. Problem number 20, they give us a formula, D is equal to R times T, and they want us to take this formula and solve it for the variable R. Currently, this formula is solved for the variable D because D is all by itself. They want us to turn the tables on this formula and solve it for R, which means I got to get R all by itself on the right side of this equation or formula. And since it's R times T, how do I do that? What's the inverse of multiplication? So in order to solve for R, I'm going to have to divide both sides of my equation by T. Therefore, D divided by T is equal to R, as the T's on the right side reduce out to 1. Ladies and gentlemen, I have accomplished my task. I've taken that formula and I've solved it for R. Any questions how I took this formula, initially solved for D and solved it for R?
Yes.
Okay, go ahead.
How do you know that you're supposed to divide?
Because it's R times T, understood here. And the inverse of multiplication is division.
Okay.
We got to get rid of the T to get R by itself. And since T is being multiplied by R, we divide both sides by T. All right, does that answer your question there?
Yes, I see it now.
All right. Just curious, does anybody know what this formula even pertains to? We don't really even need to know that. So I just thought I'd throw that out as an extra question. Anybody know what this relationship is between dr and t? Just curious. Well, it really relates the distance an object travels is equal to the speed or the rate with which it travels times the time it travels that speed, ladies and gentlemen. That's the distance rate time formula. Presently, it was solved. Initially, it was solved for the distance. We turned around and solved it for the rate. Okay, for the speed. All right, let's go on and look at another formula here. Your author gives you many, many, many to play around with in here. Hey, look at this formula, number 22. P times V is equal to N times R times T. They want us to solve this formula for the variable P. There's a lot of variables in this formula here, ladies and gentlemen. There's 1, 2, 3, 4, 5 different variables in this formula. Presently, this formula is solved for any variable? The answer is no, because you do not have a variable all by its lonesome on one side of the equation. They want us to solve this formula for P right here, this variable P. To solve for P, we need to get P by itself. To get P by itself, we need to understand a relationship that exists between P and V, which is multiplication. What's the inverse of multiplication? What makes my V go away? To get P by itself, I got to divide both sides of the equation or the formula by V, the thing I want to get rid of. So I divide the left side by V, and I got to divide the whole right side by V. When I do that, the V's reduce out the ones on the left side, leaving me with 1P or P all by itself. And that's what it means to solve for P. So P is equal to N times R times T divided by V, and we're done with this problem. We have solved that formula for the variable P. And everybody understand how I just solved that formula for P by dividing both sides by V. What if I use that same formula? What if I want us to solve for, here's a different problem. I want to solve for T. How would I get T all by itself on the right side? Understanding that it's N times R times T. How do we do that? How do we isolate T on the right side?
Divide it by T.
Well, we want to get T by itself. So
by N and R.
Yeah, we got to knock out N and R. Let's divide both sides of the equation or formula by N and R. The N's reduced to 1 on the right. The R's reduce out the ones on the right, leaving us with T all by itself. And that's what we wanted. So T is equal to P times V divided by N times R. We have successfully solved this formula for T. Let's see what's going on here. What if I wanted to solve for V? What would I divide both sides of my equation by if I wanted to solve for V?
P.
Yeah. If I wanted to solve for V, I would divide both sides of my equation by P to get rid of the P and to get the V all by itself on the left side. P's reduce out to ones, and we'd be left with V is equal to N times R times T divided by P. That's now solved for V. Does this make sense how we're solving the formula for various variables? In passing, just out of curiosity, anybody know what this formula pertains to? Have you ever seen this formula before? Anybody? This is called the equation of state, or the ideal gas law. Pressure, volume, the number of moles of gas. This is called the universal gas constant. And this is called the temperature. We solved it first for pressure in terms of the number of moles of gas, the gas constant, temperature divided by the volume of the gas. We solved it for temperature of the gas, which is pressure times volume divided by this constant, N times R. Then we solved it for the volume of the gas, which is this constant, which is just a number, times the temperature divided by pressure. Okay. You see that equation in chemistry, if you take a course in chemistry. Any questions how we solve that formula for the various variables, Liza? All right, there's loads of formulas out there in the real world. They're all around us, everywhere. Look at number 32. How would I solve that formula for y? How do we solve this formula in number 32 for y? Well, we got y plus 5 is equal to 2 times x plus 2, and we want to solve this formula for the variable y. To do that means we got to get y all by itself on the left side of this equation. So how do I accomplish that, getting y all by itself? Well, first of all, on the right side, there's a little simplifying we can do by distributing the 2 inside the parentheses. In which case, we'll have 2x plus 4 on the right side after I distribute the 2 into both these terms. Now to get y by itself, you have to get rid of a plus 5. The only way to get rid of a plus is to subtract. So we minus off 5 from both sides of our equation. 5's drop out on the left side to 0, leaving you with y. So y is equal to 2x plus 4 minus 5. Combining these like terms on the right side to simplify the right side, we get minus 1. And we have solved for y. Everybody see how we solve that formula for y? All right, number 38. They give us a formula. H is equal to VT minus 16T squared. They want us to solve this formula for the variable V. So they want us to solve this formula for V, which means we got to get this V all by its lonesome on the right side of this equation. Presently, this formula is solved for H. We want to solve it for V. That means we got to get V all by itself. What would be the first move in moving in that direction? What's the first move to solving for V? Anybody? How do we solve for V?
You divide by T.
Well, we can divide by T. We're not, I mean, you could do that, or we could just, first of all, move this whole term, first of all, over to the left side. How do you move a minus 16T squared to the left, this whole term? How do I move this whole term over to the left?
It'll be a positive.
You have to add it to both sides. So let's add 16T squared to both sides. And when I add 16T squared to the right side of the formula or the equation, it drops out, leaving me with V times T. And on the left side, we got H plus 16T squared. Finally, how do I get V by itself? How do I get rid of this factor of T? What's the inverse of multiplication? And we're going to have to divide both sides of our equation by T. The T's reduce out to 1's on the right side, leaving you with V. And V is equal to H plus 16T squared, all divided by T. And we are done. We have accomplished our task of solving for V. That's what V is equal to. Any questions how I solve for V? All right. You could have divided both sides by T first. So an alternative way you could have went about this problem here. It would be perfectly okay if you divide both sides by T. Got to divide each term by T though. So you'd have H of T is equal to, this reduces down to just V. This t reduces down to one of these t's, still leaving a t behind. So this would leave behind minus 16t. And now to solve for v, we're going to have to add 16t to both sides to bring this term over to the left. In which case you'd have h divided by t plus 16t. These drop out on the right side to 0, leaving you with v. This is equally equivalent. These two things are equivalent to each other. Ladies and gentlemen, they don't look like it, but they are equivalent. So whether you go this way, solving for v, or this way, it's up to you. Both ways work. You can kind of see that if you split this up, put h over t, you would have h over t. 16t squared over t reduces down to 16t. You can see how this is the same thing as this. These are equivalent to each other. Okay. Any other questions about that one, how we solve for v? Number 36, we have P is equal to 2 times L. That's an L, not a 1. 2 times L plus 2 times W. Does anybody recognize that formula, what it pertains to? This one's fairly common.
Length times width. Looks like it.
Well, it's 2 times the length plus 2 times the width is equal to P. What do you think that pertains to? You're getting warm, you're warm. It's the perimeter of what kind of a shape? Of a rectangle?
Yes.
The perimeter of a rectangle formula, ladies and gentlemen. They want us to solve it for L, the length. Presently, it's solved for perimeter P. How do I get this thing solved for L? How do I get L all by its lonesome? How do we get L all by itself on the right side? First move, anybody?
Take away 2.
We can take away 2W. Yeah, we can move this whole term 2W over the left side by subtracting it from both sides. That'd be a nice way to start. Hence, we have P minus 2W is equal to, these 2W's drop out on the right, leaving us with 2 times L. Good, we're almost there. How do we solve for L?
You have to get L by itself, don't you?
Yes, how do we do that?
So you would divide 2.
Yes, now we divide both sides of our equation by 2. And finally, we get these reduced down to 1. We're left with 1 times L, or L all by itself on the right side. So the length is the perimeter minus 2 times the width divided by 2. We have solved for the length. Anybody, any questions how we solve for the length? We just solved for the length. So we're solving formulas for a particular variable. You can see that there's a lot of formulas in here. All right, classwork number 2 is upon us, ladies and gentlemen. I'm going to give us a problem to work with here. All right, classwork number 2. Problem number 1. I want to take the formula P is equal to A plus B plus C, and I want you to solve it for A. Hold on a second. That's one problem. I'll show you these in a moment. And let's see. Do we have another one here? Well, let's see here. Okay. I'll just make one up. So classwork 2, number 1 is going to be this. Solve this formula for A. I'm going to make up another one here. I want you to solve the second one for P. There you go, ladies. We'll call that classwork number 2. See if you can solve these formulas for the requested variable. Solve this one for A, solve this formula for P. All right, going to solve this first one for A, which means we have to get A all by itself, which means we have to move the B and the C over to the left. And the way you move positives to the other side of the equation is you subtract. So we're going to have to subtract A. We're going to have to subtract B from both sides of our equation first. It doesn't matter what order you subtract these from both sides first. B's drop out, leaving you with A plus C. Now to get A by itself, we just subtract C from both sides. C's drop out on the right, and therefore you have P minus B minus C is equal to A. Did anybody get that solved correctly for A? All right, that's solved for A now. All right, the second one, we want to solve for P, which means I got to get P all by itself on the left side of my equation. I got to move the R, the C, and the L over to the right side. How do we do all that legally, algebraically? Okay, well, how to do that? To solve for P, I'm first of all going to move L over to the right side of my equation by adding it to both sides. L's drop out on the left, leaving you with R times C times P equal to 2V plus L. To solve for P now, we're going to have to get P all by itself. And since R and C are being multiplied by P, we divide both sides by R and C. The R and C drop out to 1 on the left side, leaving with P all by itself, and we're done. So we have solved this formula for what? The variable P. Anybody get that thing solved correctly for P? So those will be your answers there for classwork number 2. So solved the first one for A. And we solved the second one for P. All right, there's just one more section, ladies. I'm going to stand between us and the end of this this session here, and it's 10.7. 10.7 is going to have us solve what are called linear inequalities in one variable. Okay, linear inequalities in one variable, 10.7, and that's going to close the door on chapter 10 when we get done with this section. All right. Solving linear inequalities. All right. This is called an inequality statement. Is this statement true or false? And how do we even read what we're looking at? This is saying 5 is what? Five is greater than 3. Is that true or false? True or false? That's true. How do we read this statement here? This is saying 5 is greater than or equal to 5. Is this true or false to say 5 is greater than or equal to 5? That's true. No, that's true.
Oh, 5. Okay, I thought the other one said 3.
5 is not greater than itself, but it is equal to itself. So this is a true statement. All right, so what's this saying right here? How do we read this statement? 7 is less than 10. Is that true or false?
It's true.
That's true. All right, 2 is what? How do we read this? 2 is less than or equal to 2. Is that true or false? True is less than or equal to itself.
True.
That's a true statement. These are called inequalities here. Okay. All right, so we're going to be solving what are called linear inequalities in one variable. Now, suppose I give ourselves this inequality here. How do we read what we're looking at? We say x is greater than 5. So any solution to this inequality is going to be any number such that when you replace x with that number, it's going to be a true statement. So can anybody give me a number that I would replace x with and have a true statement here? Can you give me any number that is greater than 5? Are there any out there?
7.
7 works. 7's a solution. Any others?
10.
6.
10 works. 6 works. Any others?
13.
13's a solution to this inequality. Would 5.7 be a solution?
Yes.
Yep. Would a million be a solution?
Yes.
Would a trillion be a solution?
Yes.
How many solutions this thing have, ladies and gentlemen?
Several.
Several. In fact, there's probably more than several. There's an infinite number of solutions to this inequality. There's an infinite number of decimals and fractions that are greater than 5. Well, now how am I going to sit here and list them all? We'll be here to the end of time. Okay. Well, we don't do that. What we do, ladies and gentlemen, is we graph the solution set on the number line. So to graph all real numbers that are strictly greater than 5, what we're going to do here is we're going to put our number line on our paper. We're going to put 0 on a number line to establish reference. Please always put 0. 5 being positive is to the right of 0. How about 5 itself? Would 5 be in the solution set? If you replaced x with 5, is this a true or false statement? True or false?
True.
It's true to say 5 is greater than itself?
No, it's not.
This is a false statement.
False.
So I got a question for you. Is 5 itself to be included in the solution set to this inequality? Do we include 5? We do not include 5 in the solution set. We only include numbers that are strictly greater than 5. So to not include 5 in the solution set, we're going to put an open circle on 5. Open circle. And then we're going to shade to the right. And at the end of our shading, we're going to put an arrow. Ladies and gentlemen, you are looking at the graph of all solutions to this inequality. It's any number that's strictly greater than 5. Everybody understand that graph then? Why the open circle on 5 again? Why do I have the open circle on 5? What does that mean? Open circle on 5 means that 5 is not a solution to this inequality. 5 is not in the solution set. What if I change it to x is greater than or equal to 5? How's that going to change my solution set? Or does it? How is this inequality different than the previous one? Its predecessor up here. Any difference, or is it the same thing? Well, the difference now, ladies and gentlemen, is that 5 is included in the solution set, whereas up here it was not. Because now to say 5 is greater than or equal to itself is a true statement. So now we must include 5 in this solution set. So to do that, we put a closed circle on 5 and we shade to the right. There's the graph of all real number solutions that are greater than or equal to 5. Questions how we're graphing solution sets of inequalities? Closed circle means 5 is in the solution set. All right, let's try another one here. Suppose I have X is, how do we read this? X is, our solution X is less than -2. Is -2 to be included in the solution set? The answer is no. -2 is not less than itself, it's equal to itself. So to not include -2 in our solution set, we have an open circle on 2. And we shade to the left. This would be the graph of all real number solutions X such that the number is less than -2. To say our solution X has to be less than or equal to -2, now we would include -2 in our solution set. So we'll have a closed circle on -2 now, and we shade to the left. Any questions, ladies and gentlemen, how I'm representing inequality solution sets by graphing them on a number line? All right. Solving inequalities is just like solving equations. We got to get the variable all by itself on one side, and we utilize the same techniques we utilize for solving equations. There's just one big area of caution when you're solving inequalities. You got to be careful in 2 situations. I'm going to demonstrate the 2 situations where you have to take care. 14 is greater than 10. That's a true statement, correct? All day long, that's true. Suppose I divide both sides of my inequality by a -2. Do I still have a true statement? Is it true to say -7 is greater than -5? True or false? This is now a false statement. I've gone from a true statement to a false statement. What the heck just happened here? Well, what just happened, ladies and gentlemen, is I divided both sides of my inequality by a negative number. And when you divide both sides of an inequality by a negative number, you must remember something. You have got to flip the inequality symbol around. And if you don't do that, you'll have an error. So this symbol has got to be flipped around. Must flip it around if we're going to have a true statement. So to get back our truthful statement, we're going to have to do what? Must flip the inequality symbol around. Now we're back to a true statement. So try to make note of this and don't forget about this. If you ever divide both sides of an inequality by a negative number, you must flip your inequality symbol around. Don't forget that. And here's another thing you got to be careful with. We say that 6 is greater than 3 all day long, correct? True statement. What if I multiply both sides of this inequality by a number? Do I still have a true statement? Is it still true to say -18 is greater than -9? All of a sudden, our true statement has become a false statement. Uh-oh, what just happened here? What just happened is I multiplied both sides of my inequality by a negative number. And when we do that, we must also remember to flip the inequality symbol around. And if you forget that, you're going to have an error. So to get back our true statement, ladies and gentlemen, we have to, in dividing both sides of this inequality by a negative number, we're going to have to flip our inequality symbol around to get back our true statement. Must flip inequality around. So there's two areas of great concern when solving inequalities. If you ever divide or multiply both sides of the inequality by a negative number, you must remember to flip your inequality symbol around. So try not to forget that, ladies and gentlemen. Other than that, solving inequalities is just like solving equations. So those are the two areas you got to be always conscious of when you're moving through these things here. So let's go down and see if we can solve some of these here. All right, let's try problem number 2. They want us to solve this inequality for X for its solution set. So let's try to find all real numbers that satisfy this inequality of X plus 3 being less than -5. To do that, pretend it's like solving an equation. We got to get the variable all by itself on the left side of our inequality. To do that, we subtract 3 from both sides. The 3's drop out on the left, leaving you with X. And on the right side, we have -8. Ladies and gentlemen, we're done. We have solved this inequality for X. Its solution set consists of all numbers that are strictly less than -8. To graph the solution set on a number line, put 0 on the number line to establish a reference. -8 is to the left of 0. You don't have to put all the tick marks in between 0 and -8. Would I have an open or closed circle on -8? Is -8 to be included in the solution set? Yes or no? The answer is no. Open circle on -8. And we shade to the left to encounter solutions that are less than -8. There's the graph of your solution set for that inequality. We're done with that problem. So somebody give me a solution to that inequality. Go ahead. Throw out a number that's a solution. Give me a solution to this inequality. -10 would be a solution because -10 is less than -8. Would 0 be a solution? Nope. 0 is not a solution. It's not in the graphed area. 0 is greater than -8, not less than -8. All right, so all the solutions to this thing are any number less than -8. Any questions how we solve that inequality? All right, let's go down and solve another one here. How about number 16? Want to solve for A. 4A is less than 16. How do we solve this inequality for its solution set? Well, how do we get A all by itself? Since it's 4 times A, we're going to have to divide both sides of an inequality by 4. Since we're dividing both sides by a positive number, we do not flip our inequality. The 4A over 4 reduces down to A. A is less than or equal to 16 divided by 4 on the right side is 4. Essentially, that's your solution set. I would like you to also be able to graph it. Put 0 on the number line for reference. 4 is positive. It's to the right of 0. Do I put an open or closed circle on 4? Is 4 to be included in this solution set? The answer is yes. So therefore, we have a closed circle on 4. And we shade to the left to encounter solutions that are less than 4. Any number that's less than or equal to 4 is a solution to that inequality, and we're done with that problem. Any questions how we solve that one? All right, how about -3t is greater than 6? How would we solve this inequality for its solution set? Well, we got to get t all by itself, which means since -3 is being multiplied by t, we're going to have to divide both sides of the inequality by a negative number. And if I divide both sides of an inequality or multiply both sides of an inequality by a negative number, what must I remember to do with the inequality symbol? What do I got to do with this?
flip it.
Must flip it, and if you don't, you'll have an error. This left side reduces down to 1t or t, so t is less than 6 divided by -3 is -2. That's your solution set. Now we'll graph that on a number line, put 0 on the number line for reference. -2 is to the left of 0. Since t is our solution, t is to be strictly less than -2, we do not include -2, so we have an open circle on -2, and we shade to the left. And we're done. Questions how we're solving inequalities and graphing their solution sets on the number line.
I have a question.
Yep,
For the last one, why did you make the arrow go to the left?
because we're dividing both sides of the inequality by a
I mean-
negative number.
I was talking about the last problem that we did.
This was the last one we did.
I mean, the one before this, yeah,
This one?
yes.
Well, we're solving for a, so I divided both sides by 4 and got a must be less than or equal to 4.
Okay,
And so we got a shade to the left of 4 to encounter solutions that are less than 4, correct? You don't shade to the right. Shade to the right of 4, the numbers are bigger than 4, greater than 4. This is saying less than or equal to 4 must be our solution. So we got a shade to the left. And notice we include 4 because we have the equal sign as part of our inequality, correct?
correct.
So 4 is
Okay.
to be included in the solution set there.
Okay.
All right, that help?
Yes, it does.
All right, let's try another one here. All right, number 24. We want to solve that inequality for x, for the solution set of x. So we have -x divided by 9 is greater than or equal to -1. We want to solve for x here. So to solve this inequality for x, we have a negative over here, and we've indicated quite a ways back that when you have a negative fraction, it doesn't matter where you attach the negative sign. Because of that, I'm going to attach the negative sign to the denominator and call this x over -9. Now, how do we solve for x? We got to get rid of this -9 that's being divided into x, and the inverse of division is multiplication. So we're going to multiply the left side of this inequality by a -9, but I got to multiply the right side by -9 also. But wait a minute, since I'm multiplying both sides of an inequality by a negative number, got to remember to flip your inequality symbol around. Now what happens to these -9s? They reduce out to 1s, and 1 times x is x. So x is less than or equal to now -9 times -1 is +9. And so that would be your solution set. To graph all solutions that are less than or equal to 9, put 0 on the number line, 9 to the right. We'll have a closed circle on 9, and we shade to the left. You're looking at the graph of all real number solutions that are less than or equal to 9. Questions how we just solved that inequality for x? So just remember, if you ever multiply or divide both sides of an inequality by a negative number, you must flip inequality symbol around. Otherwise, you'll have an error. All right, look at number 34. There's a whole bunch of fractions in 34. But we've seen how to get rid of fractions in a fractional equation. We could probably use that same trick to get rid of them in an inequality. So to solve for the solution set in number 34, I'm going to have to get rid of all these fractions. And to do that, the magic bullet is the least common denominator of 2, 3, and 6. And what would that be? What's the least common denominator of 2, 3, and 6? Well, as it turns out, after a little thought, it's going to be 6. So we're going to multiply both sides of our inequality by 6. By doing this, this will knock out all the fractions. Since I'm multiplying both sides by a +6, I do not flip my inequality symbol around. When you multiply 6 by a -1/6 y, you're going to be left with -6/6 y. A -6 being multiplied by 1/2 is going to give you -6/2. Multiply 6 by 2/3, and you're going to have 12/3. Negative 6y reduces down to negative y. Fraction gone. Negative 6/2 reduces down to 3. Fraction gone. 12 divided by 3 reduces down to 6. Wrong. 4. Fraction gone. All the fractions disappear when you multiply both sides by the least common denominator. Now to solve for y, we want to separate the variable terms on the left, constants on the right. So I'm going to have to add 3 to both sides, move the -3 to the right side. Notice we don't flip our inequality around. Nowhere did I ever divide or multiply both sides by a negative number. Haven't done that yet. The 3's drop out on the left side of the inequality, leaving you with negative y rather. Less than or equal to 4 plus 3 on the right is 7. Now, ladies and gentlemen, we want to solve this inequality for y. We got to get y by itself. So we're going to have to now divide both sides of the inequality by a -1. And since I'm going to be dividing by a negative, I must flip inequality symbol around. Now it's time to flip it around because I'm dividing both sides by a negative. The left side reduces down to y, and y is greater than or equal to -7. That's your solution set. And we're done with this problem. To graph the solution set on the number line, put 0 on the number line for reference. -7's to the left of 0. We put a closed circle on -7, since it's to be included in the solution set, since we got the equal sign here as part of our inequality. And to encounter solutions that are greater than -7, we shade to the right on the number line, not to the left, to the right. You're looking at the graph of the solution set to this nasty fractional inequality. Any questions how we tackled that one? All right, that one's done. All right. And you can have, you can see there's fractions in a lot of these decimals. You can have parentheses that pop up in them, ladies and gentlemen. But where there's parentheses, the distributive property is not far behind. Let's see if we can solve number 56 here. So 8 subtract 6 times quantity x minus 3 is less than or equal to -4x plus 12. We want to solve this inequality for the solution set for the variable x. To do that, the left side is in need of simplifying. And to simplify the left side, we're going to have to distribute. So I don't mess the sign up, I'm going to view this as a -6 that has to be distributed in. What's a -6 times 1x? That's -6x. What's a -6 times a -3? A +18. No simplifying necessary on the right side of our inequality. Left side, we have a little more simplifying to do by combining like terms. 8 plus 18 combined to give you 26. Now it's time to separate the variable terms on the left side versus the constants on the right side. To do that, I'm going to drag this 4x over to the left side of my inequality by adding it to both sides. These terms combined are like terms. -6x plus 4x combined to give you -2x. These 4x's drop out on the right side of the inequality, leaving us with 12. Continuing to separate, I got my variable term on the left side. It means I got to move this constant 26 over to the right side. To move the positive 26 to the other side, we subtract 26 from both sides. The 26's drop out on the left side, leaving you with -2x. Less than or equal to 12 minus 26 on the right side nets us -14. Finally, ladies and gentlemen, to get x all by itself, we have to divide both sides of the inequality by a -2. Ding, 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 ding. Because we're multiplying both sides by a negative, we must flip inequality around. -2x divided by -2 reduces down to x. X is greater than or equal to -14 divided by -2 reduces down to 7. You are looking at your solution set. To graph the solution set on a number line, Put 0 on the number line for reference. 7 is positive to the right. Close circle on 7 since our solution set's to include 7. And it's also to include numbers that are greater than 7. So we shade to the right. Make sure you always put an arrow at the end of your shading. Very important. Ladies and gentlemen, questions how we solve that inequality for its solution set X. With practice, you're going to get better, but that's only going to come through practice. That's why we'll assign an appreciable number of problems to give you that practice. The pace in this class is kind of fast, ladies and gentlemen, as we're running out of time in this course. We only have 4 more meetings after today. That is it. This thing's done March 1st. All right. All right, so let's see if I can have you do classwork number 3. Ladies and gentlemen, we'll call this number 3. Classwork number 3. See if you can solve this inequality here. Here we go. Negative 2x plus 4 is less than 5 minus 3 times 2x minus 6. This is problem number 60. Go ahead and see if you can solve that inequality. We'll call that classwork number 3. Please graph the solution set on the number line. All righty, let's see how we're doing out there. Left side, no simplifying necessary. Right side, we're going to have to distribute a -3 inside the parentheses. -3 times 2x minus 6x. -3 multiplied by -6 plus 18. Left side, excuse me, the right side needs a little more simplifying. We combine like terms, 5 plus 18 to combine to give us 23. Now that both sides are simplified, it's time to separate. Move the variable terms over to the left, the constants over to the right. To move a -6x over to the left side, we add 6x to both sides. Combine like terms, -2x plus 6x, 4x. 6x's drop out on the right side to 0, leaving you 23. As we continue to separate, now it's time to move the constant 4 over to the right by subtracting it from both sides. 4's on the left drop out, leaving you with 4x. 23 minus 4 on the right leaves us with 19. One last move now to get x by itself is to divide both sides by a +4. Since we're dividing by a positive, we do not flip inequality. X must be less than 19/4. To graph the solution set on the number line, put 0. 19/4 is positive, it's to the right of 0. We put an open circle on 19/4 since our solution X is to be strictly less than 19/4, not equal to. And we shade to the left to encounter solutions that are less than 19/4. And that would be your answer. Okay, so that one's done. Anybody get that correct? Classwork number 3, ladies and gentlemen. All right. Let's see. And or ors. All right. Sometimes we run into what are called compound inequalities. And there's two types. You could have an or you could have an and. All right. Problem number 76, it's called a compound inequality because they give us two inequality statements separated by the word or. And we're going to solve this compound inequality statement or this compound or inequality. To solve it, we're going to have to solve each of these inequalities individually here. And then in the end, or means to join the sets together. Or means join. So let's solve this inequality on the left here. To do that, we got to solve for x. So we subtract 2 from both sides. 2's drop out on the left, leaving you with 3x. Less than -5 on the right. Now we divide both sides by a +3. In which case we get x is less than -5/3. Or we got the word or in between here. Now we solve the inequality on the right side. Again, by subtracting 2 from both sides. 2's drop out on the left, leaving you with 3x. And 3x is greater than 3 minus 2 on the right is 1. Finally, we divide both sides of this inequality by 3 to get x by itself. Since I'm dividing by a positive, we do not flip the inequality. So x is greater than 1/3. All right, ladies and gentlemen, the word or is called a disjunction in mathematics. It means to join sets together, or it means to find the union or take the union of the sets. The union of sets join sets together. So to graph the solution set on a number line, here's our number line. I'm going to put 0 on the number line. We need to graph this solution set and this solution set on the number line. And the joining together of these solution sets is the word or. So -5/3, I'm going to put to the left of 0. +1/3, I'm going to put to the right of 0. So any solution to this compound or inequality would be any real number that's less than -5/3. So we put an open circle on -5/3 since it's not to be included in the solution set. And to encounter solutions that are less than -5/3, we shade to the left. Or Another or a solution could be any real number that's greater than 1/3. Open circle on 1/3, since 1/3 is not to be included in the set, and we would shade to the right to include solutions that are greater than 1/3. You are looking at the graph of the solution set to this compound OR inequality. As long as we choose a number that's either less than -5/3 or greater than 1/3, it will be a solution to this entire OR statement. You see, for an OR statement to be true, all right, at least one of these component statements needs to be true. Both do not have to be true. As long as one of them is true, the whole OR statement's true. And that's why solutions to this OR statement would be any number less than -5/3, although any solution less than -5/3 would not be a solution to this inequality, it is to this one. So that's why we say any number less than -5/3 would be a solution to the entire OR. Or we could have any real number that's greater than 1/3, although not a solution to this inequality, it would be a solution to this one. And that's good enough to say it's a solution then to the entire OR. You're looking at your answer. Any questions how we solve that compound OR inequality? And we graphed its solution set. All right. Maybe we could try another one, number 82 here. Number 82 is also an OR, compound OR inequality statement. And basically it says that 2x minus 5 is less than or equal to -1, or -3x minus 6 is less than -15. So we want to solve this compound OR inequality. And to do that, we have to solve this inequality and then solve this inequality. How do we solve this one for x? Well, there's no simplifying necessary on both sides, so it's time to separate. Variable terms on the left, constants on the right. This add 5 to both sides, move the constant to the right. These 5s drop out on the left side, leaving you with 2x less than or equal to -1 plus 5 on the right is 4. Finally, we divide both sides by a +2. Since we're dividing by a positive, we do not flip our inequality symbol around. That's one part of our solution set that is compound OR inequality. But there's another one. We got to solve this inequality for x now. To do so, we add 6 to both sides. Well, hold on. We got to add 6 to the left and add it to the right. These 6's drop out on the left, leaving you with -3x, and that's going to be less than -9 on the right. Now we need to divide both sides of our inequality by a negative number. Since we're dividing both sides by a negative, we must flip the inequality symbol around. Try not to forget that. The left side reduces down to x, and the right side reduces down to 3. So there you go, ladies and gentlemen. We have 2 solution sets that would provide solutions to the compound OR inequality. Any real number that's less than or equal to 2 would be a solution. That's the graph of that solution set. Or any real number that's strictly greater than 3 would be a solution. And that's the graph of that one. And you're looking at your answer. This is the graph of your solution set to the entire compound OR inequality. That's your answer. We're done with that one. So I've shown you how to solve a couple of compound OR inequalities. The only other compound inequality that we run into is called a compound AND inequality. Number 84 is an example of a compound AND inequality that says m plus 1 is less than or equal to 3 and at the same time greater than or equal to -3. And we want to solve this compound AND inequality for the solution set for the variable m. So again, the way we read this compound AND inequality is we could say m plus 1 is greater than or equal to -3 and at the same time must be less than or equal to 3. To solve this compound AND inequality, wait a minute, how do I know it's an AND? You know, ladies and gentlemen, you know it's an AND if you don't see the word OR. If you see the word OR, you know it's a compound OR inequality. If you don't see the word or in a compound inequality, it's understood to be an and. And means intersection between sets, or means the joining of sets together. Okay, so we're going to have to solve this inequality, and we're going to have to then solve this inequality, and then we're going to have to take the intersection of the solution sets of the two inequalities. But there's an easier way. We can just solve both of them simultaneously. All we have to do is get m all by itself in between the inequalities. How do you get rid of a plus one? You minus one. I'm going to minus one from the middle, minus one from the right, and minus one from the left. The ones in the middle drop out to zero, leaving you with m. And that's what we want, m all by its lonesome in between the inequalities. So m is going to be less than or equal to 3 minus 1 or 2, and at the same time must be greater than or equal to -4. Ladies and gentlemen, there's your solution set. We just have to graph that now. So to graph all solutions to this compound and inequality that are greater than or equal to -4 and less than or equal to 2, first we graph this solution set, which is saying our solution m must be greater than or equal to -4, which means we put a closed circle on -4 and we shade to the right because our solution m is to be greater than -4. Closed circle on -4, shade to the right, but our solution m at the same time has to be less than or equal to 2. So we can only shade to the right as far as 2, put a closed circle on 2, and ladies and gentlemen, we have the graph of the solution set to this compound and inequality. Just so long as we choose a number between -4 and 2, including the endpoints, we would have a solution to this and compound inequality. So I got a question. Is 3 a solution to this compound and inequality? The answer is no, because 3 does not lie in the graph solution set. Would -6 be a solution to this compound and inequality? The answer is no, because -6 does not lie in here. So the only solutions are between -4 and 2. All right, let's try one more and wrap it up. Let's see here. Okay, I'm going to do number 94. It does have one fraction in it, and I'll show you how to handle this. No big deal. Number 94. So we got -3 is less than or equal to -1/3 x minus 1, and at the same time that has to be less than 2. We're going to solve for the solution set for this compound and inequality. To solve for x means to get x all by its lonesome in between the inequalities. To move in that direction first, I'm going to get rid of the -1 by adding 1. I'm going to add 1 to the left, add 1 to the middle, and add 1 to the right. These ones drop out in the middle, leaving you with -1/3 x, which must be less than 3 and at the same time greater than or equal to -2. Finally, to get x all by itself, I'm going to multiply all sides of this inequality by a -3. But since I'm multiplying both sides of an inequality by a negative, I must flip this inequality symbol around. Must flip this inequality symbol around. And therefore, -3 times -1/3 x is just going to be 1x, 1x or x. So x must be less than or equal to 6 and at the same time greater than -9. So how do we graph all real numbers that are less than or equal to 6 and at the same time greater than -9? Well, we put our number line down, put 0, put -9 to the left, put 6 to the right. Our solutions have to be what? Less than or equal to 6, meaning we have a closed circle on 6 and we go less than 6 down to, but our solution at the same time has to be greater than -9. So we have an open circle on -9, and that's it. Ladies and gentlemen, you are looking at the solution set to this compound and inequality. Any number that lies between -9 and 6, including 6, but not including -9, would be a solution to that inequality. Any questions how we solve some compound and inequalities? All right, you have a great day. I will eventually make chapter 5 and 6 quiz available. Please try to get that midterm exam done and get it to me, ladies and gentlemen. And I will also update your homework. All righty, have a good day. Hopefully I'll see you in a couple of days. Any remaining questions or concerns, Michael?